In this video, I'm going to talk about integral calculus. Now, suppose we have, let's say we have a function y equals to s squared, right? And we are asked to find the y by the x. That is, we are asked to find the change in what in y and change in x, right? So in this scenario, if we basically differentiate this x, we find the derivative of s squared. That's going to give us 2x, right? Now let's calm down and look at this. Whenever you're talking about changing y and with changing x, that shows that we are actually differentiating a function with respect to what x. And in this scenario, y is the dependent variable, while x is the what independent variable. That shows that if there is any change in what in x, there will be change in what in y, right? So what I want to explain here is that, look at this. Since we find the derivative of the y of this s squared, we have 2x, right? Now let's say we are to integrate 2x, right? So finding the integral of 2x, we end up, let me split 2x dx, we end up having 2s squared divided by what 2, right? And in this scenario, this cancels this out, right? Then the final answer that we have is actually what s squared. Now look at this. If you differentiate s squared, you're going to have 2x. If you integrate 2x, we are going to have s squared, right? So that shows that these two processes are actually inverse of each other, right? They are actually inverse of each other. So in that scenario, I will simply define integral calculus as the reverse of differential calculus. That is the reverse, the opposite of differential calculus is what's referred to as what integral calculus. So an integral is defined as what as a reverse process of differentiation. If we are going to define it like that, so it is a reverse process of what of differentiation, as can see, right? It's just like if I integrate this guy, if I differentiate this guy, I'm going to have 2x, and if I integrate this guy, I'm going to have what? I'm going to have s squared, right? So that's just it. So integral calculus is actually the reverse process of differential calculus. And we have two major types of integral calculus. We have the one of definite integral calculus, and also we have that of indefinite integral calculus, right? So what happened here is that between the definite and also indefinite integral calculus is that whenever we are integrating, right, and at the cost of integrating, we are actually integrating with limits, right? We are integrating with limits. In this case, this whole thing is reversed as definite integral calculus, and the reason why it is definite is because it is actually being defined. That is, the value of x is defined by this limit, this lower and also the upper limit, right? So that shows that in this kind of situation, this is a definite integral. A definite integral is a type of integral that has what limit, right? That is, it's basically calculates the accumulation of quantity within this range. Just like, let's say I have a distance down, right? Let's say this is the initial and this is the final. So in order for me to calculate this, let me just say distance between this a and b, what I need is actually what I need the initial value and also the final value. So in that scenario, by the time I fit it into the integral of x, I'm going to find the main value for this x. So in that scenario, it is defined, and whenever it is being defined, there is no need to add plus c, right? So plus c simply represents that you can put any constant here and you're going to get a particular value, right? That is, at a particular time or at a particular function, this x has a value of this, and once you put it into integral of x, you are going to get a value, right? But in this scenario, whenever you're talking about definite integral simply means you are integrating with limits, right? So that's just it. You are integrating with, whenever you are integrating with limit, that shows that the integral of x is defined, and in that scenario, you simply say this is a definite integral, right? So in the case of indefinite integral, it's very simple as well. It is actually straightforward. So in that scenario, let's say you are integrating with x dx, and in this case, whatever value you get, let's say which is let me say which is s squared, that's s squared over 2, that's what you're going to get here. plus c, right? So in this scenario, I'm adding plus c here. That shows that this particular integral, it is indefinite integral. It is indefinite integral because I'm not integrating with what? With limits. And whenever I'm not integrating with limits, that shows that the value or the integral of x is not divine. And that's why we call it indefinite integral. Because whatever value, whatever expression you get, you can always put any value, any constant value, and you're going to get what? A value. You understand? And you're going to get something, right? So what I'm basically saying is that now suppose we have x ranges between, let's say, x 1, 2, 3, 4, and 5, right? So what it means is that once you put 1 inside this value, you're going to get what? You're going to get a value. If you put 1 there, you're going to have 1 over 2, right? If you put 2 there, you're going to have what? You're going to have that's going to be 2, right? If you put 3 there, you're going to get it any value. That shows that at a particular value, at a particular constant value, if you put it inside x here, you're going to have what? A specific value. So in that scenario, it is indefinite integral because we are not integrating it with limits, and the value of x is not what? Is not divine, right? It's not divine by what? By let me just say by an interval. That's why we are not integrating with limit here. Do you get it now? So that's exactly what it means. So we have two types of integral calculus. We have the definite integral calculus and also what? The indefinite integral calculus. Definite integral calculus has to do with what? With integrating with limits. When you are integrating with limits, it calculates the accumulation of a function within a limit. While indefinite integral calculus does not have what? A limit. Right? So it doesn't have any specific value that you're actually calculating. That's why we always put this plus c there. Right? So that's why you always see us writing plus c there, because we are not integrating with limits. So that's exactly what it means. Now let's simply move to the integral rule, basic integral rules that we have. So when it comes to integral calculus, we have different type of rules, right? So the rules actually start from some constant rule. So it's ranged from constant rule. From constant rule, it's moved to we have power rule. So we have many type of rules I'm going to talk about in this video. So you just have to calm yourself down and grab a pencil. Now let's start. So the first rule that we have, I would actually like to classify them based on what? On their function, right? So let me just say integral. Whenever you want to integrate integral of algebraic function, right? So let me just clap, because we have different rules under this one, right? Whenever you want to integrate any whenever you integrate algebra function, so we have like about 5 rules here. So first one is whenever you are asked to integrate a constant, which is the x, it is actually what? X plus c. It's very, very important for you to note that. And the reason why is that if you integrate the x, d will cancel integral. No, they are reverse of each other, right? They are reverse of each other. So just like positive and negative, if this is positive, this is negative, they will cancel out. They are going to let plus with x. So it is x plus c. Then the next one is that whenever you are asked to integrate c f of x, right? C f of x is x. So c is a constant here. You have to bring it out. So you bring it out. C integral of what? Of f of x. F of x is the x. That's exactly how you're going to solve it. And the reason why is that c is a constant. You have to bring it out of what? Of the integral. Yeah. So that's exactly what you have. So that's how you're going to solve it. But one thing I want to know is that I will later solve different questions on each rules, because this is a rule for constant rule. This is another rule for this is a constant rule. This is another constant rule actually, right? And then I'm going to solve different questions. So this is constant rule. The first one is constant rule. This second one is actually constant. We call it constant multiple rule, right? I'm going to solve a question on that as well. So another thing I want you guys to understand is that if you are given integral of, let me just say this is f1 of x plus f2 of x, right, plus f3 of x minus f4 of x, sorry, f4 of x. So let's just say plus you are not having the x here, right? So if you are asked to integrate this kind of thing, you are going to separate. This rule is basically called sum and difference rule. You are going to separate everything. You're going to have integral of f1 of x dx, right? Then followed by plus integral of f2 of x dx, right? Then followed by integral of f3 of x, right? Then dx. then minus integral of f4 of x dx. So that's exactly how you are going to integrate it. You are going to separate. So this is called this constant rule. This is called the constant rule, right? While this one is called constant multiple rule, right? So this one is called sum and what? And difference rule. Sum and difference rule. So that's basically what this is called. So you have many other rules I'm going to show here, right? I'm going to show here, right? So let's just go ahead. So the next rule that we have still under algebraic function is actually the power rule. Whenever you have integral of x is power n, you are going to have the x. This is basically x is power n plus 1 divided by what? X is power n plus 1, right? So then you're going to have plus c. So one thing about n is that n can actually be equals to, let me just say it can be plus or minus 1. What I mean by the plus or minus 1, 2, up to n. You understand that it can be anything. That shows that n can be what? Can be anything. It can be even, it can even be it can be 0 as well. You understand? N can be what? Can be 0. N can be 0, right? So it can be 0. That's one thing that's good. But one thing is that n must not be equals to minus 1 actually, because once it is equals to minus 1, it is another rule actually. That's under logarithmic rule. You understand that? So n must not be equals to minus 1. It can be equals to anything, even 0. It can start from 0. It can start from 2 up to anything. But n must not be equals to what? Minus 1. Because it just comes to square inverse. If you have x is power minus 1, this is creating what? 1 over x. And integral of what? Of 1 over x dx is going to give us what? The natural logarithm of what? Of x plus c. That's what you are going to have. So n must not be equals to what? Minus 1. Because you are not going to get the value at all. You're not going to get the value. You're going to get another thing entirely. And that's going to be error, math error. I'm going to show you now. Now, suppose n is equals to minus 1. N is equals to minus 1 dx. I'm going to follow this particular rule. We're going to have it to go to the x is power minus 1 plus 1 divided by what? Minus 1 plus 1. And in that scenario, this is basically x is power 0 divided by what? 0. So what is this? This is error, math error. You understand that? So we don't have any integral value for it. So that's not that x must not be equals to what? It must not be equals to minus 1. So it can be equals to negative anything actually. You understand? It can be equals to negative anything except negative 1. So you have to bear that in mind. So that's just the rules under algebraic function. Now let's move to the case of exponential function. Exponential function. So under exponential function, if you are asked to integrate integral of what? Of exponential u du, integrating this is still the same thing as writing what? Exponential u plus what? Plus c. That's what you are going to have if you integrate it. Now the next one, if you are asked to integrate integral of a raised power u du, right? Note this one that you are seeing here is different from what? From this one that you are seeing here. If you look at it very well, they are actually what? Different, right? This one is exponential u. This one is a constant raised power what? Or something. That's what you are seeing here. So it is different. So if you are integrating anything like this, you are going to have it to what? You're going to have it to a raised power u. Then you're going to have in the natural logarithm of what? Of a plus what? Plus c. Right? And then what you have to know is that a must be greater than 0, right? Or it must what? A, and then a must be greater than 0 and a must not be equal to what? 1. That's when the result is applicable. So there anything a must greater than what? Must greater than 0. That's what you have to understand here. And then a must not be equal to what? 1. That's just it. It must not be equal to 1. So that's what is under exponential function. Now let's move to another function here. So another function that we have is the case of logarithmic function, but I will still talk about that one in identity, right? So now let's go. So the one that we have is natural logarithm, right? So I'll still talk about all the identity actually because it has an identity. Natural logarithm. So under natural logarithm, we only have one rule, and that shows that whenever you are integrating the u with respect to u, whenever you are integrating the u with respect to u, you are going to have the natural logarithm of what? Of u, right? Plus what? Plus c. The natural logarithm of what? Of u plus c. That's what you are going to have, and that's the only rule that we have under logarithm, right? Now let's move to the next function. Whenever you want to integrate another function, and that's going to be the what? It's going to be trigonometry, right? It's going to be trigonometric function, right? Whenever you want to integrate any trigonometric function, so if you are given integral of what? Of sine x dx, Whenever you are asked to integrate sine x dx, it's simple as writing what minus what cos x plus c. Right, that's what you have. So whenever you are having integral of what integral of cos x dx, that's going to give us what sine x plus c, right? So if you are given integral of what of sec square x again, sec square x dx, this just repeat to give us tan x plus c, right? That's what you are going to have. You are asked to integrate integral of sec square x, you're going to have tan x plus c. Then if you are given integral of sec x, right, tan x then dx, this is going to give you sec x plus c. Take note of this. We are having sec x tan x, right? Then you're going to have it to be sec x plus c. Whenever you're asked to integrate it, because you're going to use substitution method. Then if you're asked to integrate cosec square x dx, you're going to have the answer to be what? To be minus cot x plus c. That's what you're going to have. Minus cot x plus c. That's what you're going to have. So now let's move ahead to the next one, right? Let's move to the next one. So the next one I'm having is that whenever you're asked to integrate integral of what of tan u du, whenever you're integrating, you're going to have this word to be minus ln cos what cos u plus what plus c. Now the reason I use u here is that it doesn't mean that maybe this one has to be what x every time. It can be any variable. You understand what I'm saying now? So you represent any variable. You understand? Any alphabet you want to use. You can choose to use p, you can choose to use d. It doesn't matter. You understand? So that's just it. So let's just go ahead again. So whenever you're asked to integrate another one, let's say we have cot u du, this is going to give us ln sine u plus c. That's what you're going to have. Now let's move to the next one, because you have many rules under this integral, right? You have many rules, many integral function, and also their rules. So you have to understand each and every one of them one by one, when to apply them, right? So if you are integrating cot u du, you're going to have ln what sine u. The next one is that if you are integrating another one, which is actually the what, if you are integrating, let me say sec u, or let me say sec x dx here, you're going to have the dash agreement of sec x plus what plus tan x, right, plus tan x. Then you're going to have plus c here. That's what you're going to have. So, and if you're asked to integrate cosec u du, you're going to have it to be that's going to give us a natural agreement of cosec u, right? Then minus what? Minus cot u. Then you're going to have plus c here. So that's what you're going to have. So this is everything that you have under trigonometric function. Remember that we have trigonometric function and we have inverse trigonometric function. That's what you should understand. So everything that is here is actually what you can use when it comes to trigonometric function. As you can see, there is no inverse here, right? So now let's move to inverse trigonometric function. It's very, very important. So you guys will have to put them down one by one. Understand? I've divided everything. I divided it into each under each function. Each rule I actually divide it under each function so that you guys can know when to apply it and when not to use this one. So now the next one we have is actually the inverse trigonometric function, right? Inverse trigonometric function. So you have to put everything down. So under inverse trigonometric function, the first one that we have is actually what, whenever you're having integral, let's say you're having integral of here is du divided by what, root of this is going to give us a squared minus u squared. So whenever you have this, there is actually a proof to this. And as I said earlier, I'm going to solve question on every single thing. I'm going to solve question on it. So the question on this rule, I'm going to solve it. You understand? So make sure you check the playlist. I'm going to solve everything. Now, whenever you have integral, whenever you're asked to integrate anything of this form, you have to find integral of this sum. This will actually give you what? Sine inverse, right? It's actually 1 over 1. And 1 over 1 is what? Is still 1. Sine inverse of what? Of u over a, right? Then plus c, right? So a must be greater than 0. That's one thing that you need to understand, right? So that's it. So the next one that you can have under this inverse trigonometry is actually you're having integral of du divided by a squared plus what? Plus u squared. right? So whenever you're giving something like this, you're going to have to what 1 over a, then you're going to have tan inverse of what of u over a, they are going to have plus what plus c. And in this scenario, a must not be equal to 0. That's what you need to understand here. That's the rule. A must not be equal to 0, because if a is equal to 0, there's nothing to do here. If a is 1, there's something to do, because 1 squared is still what 1, right? Abinam. So in that case, root of what root of 1 or what all squared is still the same as what 1 squared. So you have to understand it. It's still the same thing as writing what as writing 1, right? So a can be equal to 1, but it must not be equal to what 0. Because once it is equal to 0, what you have to do, you might not apply the rule. The rule will not obey the rule. That's just it. So make sure you take note of that. And I'm going to solve question on it. Don't worry. So the next one that you can have is actually when you're talking about integral, right? Integral of what of the u divided by what you're having u, then you're going to have root of u squared minus what a squared here. So whenever you're given anything like this, so this is the same thing as writing what 1 over a, right? Then sec inverse of what of u over a, then plus c. That's just it. A must be what must be greater than 0. That's just the rules that is there. So whenever you're asked to integrate integral what of this form, you're going to have 1 over a sec inverse of what of u over a plus what c. That's exactly what you're going to have. Now let's move to the next ones that we have under the inverse trigonometry method, right? So we have many of them. So let's go ahead. So in that case, the next one that we have here is actually you are asked to find the integral. Let me just say integral of still under trigonometry function. We also have, I think that's the three that we have actually. So the next one I can have is actually when you're talking about the integral of let me just say integral of hyperbolic function is also very, very part hyperbolic function. So I actually divided everything, all the rules under different function that we can have. So this is under hyperbolic function, that is you are having cos, sine, all those stuff like that, you should understand. So if you have to find the integral of sine u du, sine hu du, that's sine u du, that's going to give us what cos u plus c. That's what you're going to have. So the h actually indicates that it is an hyperbolic function. You get. So in that case, if you are asked to find integral of hyperbolic function of what of cos, right, x dx, so this is as well as what as sine x plus what plus c, sine x plus c. Note the h is there, represents the hyperbolic function. Then the following one, you are given integral of what of sec h squared, right? You're going to have x dx, right? Here is going to be give us what tan plus c. That's what you're going to have. Hyperbolic function of what of tan plus c. That's what you're going to have. Then the following one, if you're asked what to integrate, let me just say sec x, right? Then the following was what tan x, then dx. Here what you're going to have is actually what minus sec x plus c. That's what you're going to have. Don't mind me, it's somehow like oh, it's so let's move to another one. I hope you guys have actually take this note of this. So make sure you take note of it. It's very, very important, right? So let's just move to another one that we can have still under hyperbolic function, right? Hyperbolic function, still under hyperbolic function. You have to know that they're still under hyperbolic function, right? So now the next one you can have is actually when you are given integral of what of cosec squared, right? X dx. So that is going to give us what minus cot x plus c. That's what you're going to have. The next one that you can have is actually when you're talking about integral of let me just say they're giving tan x dx, right? The h indicates the hyperbolic function, then you're going to have it to be what the natural logarithm of what of cos u plus what plus c, cos x actually plus c. So that's what you're going to have. Then the next one that you can have is when you're given integral of what of let me just say cot x dx. So this will give you plane sine x plus c. So one thing I want you guys to understand is that I'm going to solve question on each function. So you have to take note of that. I'm going to solve question on them. So make sure you write all the identity down so that you can actually understand everything. You can understand the integral calculus very well, because we have many functions and there are different approach to each function. So the next one you can have is when you're giving integral of what of let me just say you're having sec u, or let me say sec x, the x here. So you're going to have it to be 2 tan inverse of what, of exponential u, right, plus what, plus c. That's what you're going to have. Exponential x rather, because we are using x here, right? So that's what you're going to have. So that's another identity still under hyperbolic function, right? Still under hyperbolic function. So you guys have to take note of that. So the next one you can have is actually when you have integral of what, of let me just say cosec x dx, right? Cosec x dx. So this is going to give us inertial logarithm of tan hyperbolic function of tan x over 2, right? They are going to have plus c. That's what they're going to have. So that's just everything under hyperbolic function. Now let's simply move to the next one that we can actually have. The next one I can have is the inverse hyperbolic function. You know, this one is not my hyperbolic function, but still under trigonometry function. We have under trigonometry function, we have the normal trigonometry function, we have the normal trigonometry rules rather. Then from there we have the inverse trigonometry rule. Then we have the hyperbolic function. Then we are going to have the inverse hyperbolic function now. So that's exactly what I'm going to write down. So inverse hyperbolic function is actually very important as well, right? So that's what I'm going to talk about here now. So inverse hyperbolic function, right, is very, very important as well, right? So now let's go ahead and check it out, right? Under the inverse hyperbolic function, we have like 3 rules actually. So the first one that we have is actually when you're given integral of the u divided by what, let me just say this is the root of u squared plus what, plus a squared. Whenever I'm giving something like this, it's same as writing what, as writing sine inverse of what, of let me just say u over a, right, plus what, plus c. That's what you're having, right? So all you have it to be what, to be inertial logarithm of u plus what, plus root of what, of u squared plus what, plus a squared, right? Then you're going to have plus c, right? And in this scenario, whenever you're having this kind of answer, that shows that a must be greater than what, than 0. A must be greater than 0, right? So whenever a is what, is greater than 0, it's a condition. You're going to have either this as the answer or this as the answer. So regardless of which one you choose, it's still the same answer. You're getting the answer. You understand? So that's just it. So the next one I can have is actually when you're having integral of du in this case, then you're going to have root of, when you're having roots, you're going to have, here is going to be u squared, then minus what, minus a squared. You know, this is plus, this is minus. Then the next one you're going to have as the answer is actually the cos, right? Cos inverse of what, of u over what, over a plus c. Or you have the answer to be ln what, ln u, right? Then plus what, plus root of u squared, right, minus, in this case it is minus, not plus, right? Sorry, it is minus. So u squared minus a squared, right? Then that's what you're going to have. Then you're going to have plus what, plus c. And as well, a must what, must be greater than a, and must be greater than what, 0. That's exactly what you have here. That is, u must be greater than a, rather. It is greater than a. U must be greater than a, right? That's it. And a must what, must be greater than 0. So that's when you can apply this rule. So now the next one I can have, let me just move to the next one I can have here, right? So that's what you can have, which is the last one. So make sure you take note of all these rules and make sure you note them down. It's very, very important, right? And we are going to solve many questions on it. And don't forget that this is actually a video series on integral calculus, and I'm going to explain everything you need to know, how to approach different questions, how to solve it. You understand? So make sure you stay with this video to the end, and then at the same time make sure you watch many of the questions. I'm going to solve a lot of questions, and check out the playlist. Do you get it now? So now let's move to the next one. So the last one you can have is when you're given integral of the u, right? Then divided by what, here is a squared minus what, u squared. So in that case, you're going to have a bulk of answers, right? That's what you can have. The first answer you can have is actually 1 over a, right? Then tan inverse of what, of u over what, over a plus what, plus c. That's the first thing you can have. And don't forget, this is normal answer to it. This is just hyperbolic function, and that's just the reason you have negative. You know, suppose you have a positive here, it is actually 1 over a tan inverse of what, of a of u over a plus what, plus c. That's exactly what you're supposed to have. But in this case, since it is minus, it doesn't obey the trigonometry rule, the trigonometry inverse rule. It doesn't obey it. So this is the one that we're going to have. So whenever you're asked to integrate the u over a squared minus what, u squared, so this is the answer you're going to have. right? This is the answer you're going to have. So once you have this, and in that case, you can only have that if magnitude of what of u is less than what, less than a. That's when you can have that, right? So all you have 1 over a, then cut inverse of what, of u over what, over a plus c. That's another thing that you can have. And in this case, whenever you have this kind of answer, that shows that the magnitude of what, of u is must be greater than what, a at that case, right? So the magnitude of what, of u must be greater than a. Now the last answer that you can have under this hyperbolic function is actually, right, is actually, let me just bring it out. So the last answer you can have is when you have 1 over 2a, right? Natural log of what, of a plus u, right, divided by what, a minus u, right? Then you're going to have plus c. That's this last answer that you can have, and you can only have that if u is not equal to what, is not equal to a, and what, and a is not what, equals to 0. That's only when you can have this answer. So you have to take note of this by noting everything down, because it will really be of help at the long run. Because I'm going to reverse once I get to each function, I want to integrate them. I'm going to reverse to what, I'm going to refer to the rules under the function, because there are so many rules and there are so many functions. So once you get to each function and how to integrate them, you are going to obey the rules. So you guys should understand and follow this thing up, because there's no way you are going to solve many questions under the rule and you are not going to understand it. You understand the whole concept of it. You understand? You get it. So once I get to a particular rule, once I get to a particular function, all the rules under it, we are going to solve it, and we're going to solve many questions on it. So make sure you take down everything, all the rules I actually explained in this video. It's very, very important, right? So if you enjoyed this video as well, don't forget to like, share, and subscribe. And then make sure you check our video out. So make sure you check the playlist out. You have many questions on integral calculus. And at the same time, if you wish to check out the Patreon account, I'm going to drop the link in the comment section below. Or simply you check what the let me just say the community. I'm going to drop the Patreon link there, so you can have access to the full video on this integral calculus. So if you enjoyed this video as well, make sure you like, share, and then at the same time, don't forget to subscribe. Thanks for watching.